sklearnutilssafesqr. Description: the safesqr function in scikit-learn sklearn is designed to calculate the squared value of an input while handling potential numerical issues, specifically preventing overflow and ensuring consistent results. Inputs: x, the input value for which the squared value needs to be calculated. This input can be a single number or a numpy array. Outputs: the squared value of the input x. This output will be a single number or a numpy array, matching the shape of the input x. Steps: if the input x is a numpy array, the function will iterate through each element of the array and calculate the squared value individually. For each element in x, the function will perform the following: calculate the absolute value of the element absx. Calculate the square of the absolute value absx2. If the squared value exceeds a predefined threshold np, finfox, dtype.max, it will clip the result to the maximum value of the data type to avoid overflow. Metrics: none, the function doesn't have specific metrics associated with its output. Visualization plots: none, there are no inherent visualization plots specific to this function. Fine-tune parameters: none, the safesqr function doesn't have any parameters that can be adjusted or fine-tuned. Uncertainty methods: none, the safesqr function is a deterministic operation and doesn't involve any uncertainty or probabilistic methods. Challenges and fixes. Challenge 1: overflow. Sample use case: when dealing with very large numbers, calculating their squares can lead to values exceeding the maximum representable value for the data type, resulting in overflow. Fixes: the function mitigates this issue by clipping the squared value at the maximum representable value of the data type, preventing overflow. Challenge 2: handling negative values. Sample use case: squaring negative numbers can lead to unexpected results if not handled properly. For example, the square of -5 should be 25. But some implementations might produce a different result due to rounding errors or data type limitations. Fixes: the function uses the abs function to ensure that the calculation is performed on the absolute value of the input, guaranteeing a positive result. This approach ensures consistency and avoids any issues with negative values.